Welcome back for part 2 of your 4A review for IM Algebra 2. Here we are, back at Bologna High School, right? A medication has a half-life of 4 hours after it enters the bloodstream. A nurse administers a dose of 225 milligrams to a patient at noon. So what we're going to do is we're going to let T equal the number of hours after noon. Then our function for the amount of medication in the bloodstream is A of T equals the initial amount times, it says half-life. That means 1/2 is the growth factor or the decay factor. Raised to the, it says 4 hours, so it's going to be T over 4. That's the exponent. This is 225 times 1/2 raised to the T over 4. So we want an expression to represent the amount of medication in milligrams in the patient's body at 1 p.m. How many hours have passed from noon to 1 p.m.? So this one is going to be A of 1, which is going to equal 225 times 1/2 raised to the 1/4. We can type that in the calculator. 225 times 1/2. I'm just going to put 0.5 if y'all will let me. And then raised to the 1/4. Hit enter. So we got 189.2 milligrams. What about 7 p.m. the same day? How many hours after noon is 7 p.m. the same day? 8. 7. How about 8? 7. 7 hours.
Is it? Oh, yeah, it's 7.
Yeah.
Oh, yeah, right.
A of 7. So we're going to do 225 times 1/2 raised to the 7/4. Go up here and copy this. And we'll change that to 7. 66.9 milligrams. That's all right. Now you know.
6.9.
Yes. Now here's the deal. The expression 225 times 1/2 to the 5/2 represents the amount of medicine in the body at some time after it's administered. What is that time? Listen, 5/2 is equal to our T over 4. It's taking the place of the T over 4, is it not? Can you solve it for T? What would you do to solve it for T? Multiply both sides by 4. That cancels here, gives you T. This gives you 20 over 2. What's 20 divided by 2? So we're talking about 10 hours after noon. What time is that? At 10 p.m. That's all there is to it. That's all there is to it. Y'all, this is so much fun. Let's do number 6. It's fun too. Number of employees in the company growing exponentially by 10% each year. By what factor does the number of employees change? Let's do our function again. Our A of T is equal to A naught times, if it grows exponentially by 10% each year. That means after 1 year, it's 100 plus 10%, or 110%, which we would represent as a decimal as 1.10 raised to the T.
Tanner Bolt, come to the hospital office to check out.
We want the factor that the number of employees changes. This is the factor we start with in years. So this wants to be 1.10. There are 12 months in a year, so 1 month is 1/12 of a year. So 1.1 raised to the 1/12. Or 1.008. Every 3 months. How much of a year is 3 months? It's 1/4 of a year, or you could say 3/12 because there's 3 months out of 12, right? So 1.10 raised to the 1/4, because that's 1/4 of a year. We're going to go up here with 1.1 raised to the 1 divided by 4. 1.024. Or if we want 20 months, 1.10. Let's just say 1 month is, or 1 year is 12 months. So this is going to be 20 divided by 12. So we're gonna type in our calculator, 1.1 raised to the 20 divided by 12. And get 1.17. We'll go ahead and put the 2 since we carried everything else 3 decimal places. That's how you do those. That's all there's to it. It's a painless process, y'all. Painless process. We're only 5 minutes in. Let's go ahead and do number 7. The value of a truck decreases exponentially since its purchase. 2 points on the graph show the truck's initial value a decade afterward. 1 decade. 1 decade is how many years? This is 10 years. We need to remember that, okay? 1/2 of a decade would be 5 years, wouldn't it? You all agree with that? All right. So we want to express the car's value in dollars as a function of time, D, in decades since purchase. We'll put it over here. Hey, our value, our A of T, is equal to the initial value. What was the initial value? 40,000 was the initial value. Times, this is going to be our growth factor, our decay factor, where we take the second value divided by the first value. So 24,000 over 40,000. And that's raised to the, and this is in decades, so we're going to do 1 decade, or T, over 1. That's A. Now it says write an expression to represent the car's value 4 years after purchase. So 4 years is 4 divided by 10 decades, right? It's 4/10 of a decade. So B becomes A of, and this is going to be 4 over 10. Number of years over the number of years in a decade equals 40,000 times 24,000 over 40,000 raised to the 4 over 10. And we can go ahead and type that in the calculator. Look where it ought to be. It ought to be somewhere 30,000, 35,000, between $30,000 and $35,000, what we should say. So we're going to type in 40,000 times, in parentheses, we got 24,000 divided by 40,000 raised to the 4/10. $32,607. About what you would expect after 4 years, right? About what you expect. Part C says, by what factor is the value of the car changing each year? Show your reason. That factor is going to be 24,000 divided by 40,000. That's our growth factor per decade. Now, each year is 1/10 of a decade, right? So we're going to raise it to the 1/10. So we're going to do 24,000 in parentheses divided by 40,000. That's all in one set of parentheses, by the way. Raised to the divided by 10. That's going to be 0.95. And that is the end of our second video, 8 minutes and 45 seconds. Thank you for watching. I hope you enjoy.